Welcome to part 4 of section 3.4, where we will talk about the complex conjugate and find them. In general, a conjugate in mathematics of a binomial is when you just flip the inside sign. So instead of 7 plus x, it would be 7 minus x. And then a complex conjugate is when we have the same real part but the opposite imaginary part. So if we were to write out the complex number 15 minus 2i, its conjugate would have the same real part, 15, but then the opposite imaginary part. So instead of a minus 2i, we'd have a plus 2i. So this is the original right here, and this is its conjugate. In math, we use conjugates a lot when we're dealing with imaginary numbers or complex numbers, and we also use them a lot when we have radicals. This makes sense because I is a radical. It's the square root of -1. We multiply a number times its conjugate because we want to get rid of the issue, which usually is the radical or is the imaginary term, and we'll see that a little bit later in this video. For notation, if we let z be a complex number, the way that we denote its conjugate is a little line over z, like this, right here. So when you see a complex number, it can have a usually lowercase w or z. We don't use x or y because those are used for variables. But if z is a complex number, then z bar is the conjugate of z. And usually this bar above something means like opposite in math. So in this case, it means a conjugate. Next, we are going to find each conjugate. So for number 1, this is a complex number. The real part is just a 0 out in front. So instead of 0 minus 7i, its conjugate would be 0 plus 7i, or just positive 7i. In number 2, we have the complex number -5 plus I. Its conjugate would have the same real part, -5, but then an opposite imaginary part. So instead of plus I, it would be minus I, so -5 minus I. And for number 3, the complex number is 4 minus 3i, and so its conjugate would be 4 plus 3i. Yes, this is as simple as it seems. Let's see why we care about the conjugate in this last example. Here we are told that z is the complex number 2 minus 3i. We want to perform the operation to find z multiplied by its conjugate, z bar. Well, the first thing that we want to do is recognize what z bar is. Z bar would be the conjugate of z, which would be z plus 3i. Let's multiply z times its conjugate, z bar. So z times z bar would be 2 minus 3i times 2 plus 3i. When we do this multiplication, we'll have 4, then plus 6i, then minus 6i, note how those cancel, and then minus 9i squared. When we combine our like terms here, they cancel out, so we're left with 4 minus 9, and we'll replace the I squared with what it equals, -1, a real number. So this is really 4 plus 9, or 13. Note that when we multiply a complex number times its conjugate, we rid of the imaginary part. We have turned our product into a real number, and that is why this is important. If we do not wish to have any imaginary parts, we can multiply a complex number by its conjugate to rid of the imaginary part.